Now, waves in bounded medium. Continuation of the topic we have done in the last session. And I'll tell you that velocity of progressive wave in solids or in a medium. This is what? Velocity of progressive, no, this is longitudinal, better to say. Longitudinal or transverse? No. Longitudinal wave. Okay, root E by rho. E stands for what? Elasticity, rho is the density. But this formula is not verified yet. Whether this will be true in solids only, solids and liquids, but not gases, that is not verified. We need to verify it. Okay? And this, you know, this is Newton's formula. Omnipresent, he is there in every topic in physics. Newton's formula. V equal to root E by rho. It is mathematical proof also. Dimensionality is not mathematical one. Later on I will show you. Now for solids. What is going to happen for solids? Tell. For solids, E can be replaced by what? Y, the Young's modulus. Remember? E can be replaced by Y. So V equal to root Y by rho. Let us verify in still only one solid. Let us verify. Now for steel, Y equal to, as I remember, 2 × 10⁻11 Newton per meter square, and rho is what? 7.9 10⁻³ kg per meter cube. So V in steel, one solid is 2 × 10⁻11 divided by meter per second. So this, if you calculate, it will be approximately 5130 approx meter per second. So by using Newton's formula, in steel, the theoretical value we are getting 5130 meter per second. Practically, Newton involves time, mn to the power minus 2, forgot. Practically, V is same, 5130 meter per second. So what will be your comment? Therefore, velocity of sound is longitudinal wave, that I told you. In steel, has the same observed value. So Newton's formula is correct for solids. Done? Newton's formula correct for solids. Now go for liquids. For liquids, formula is this. For liquids, yes, E can be replaced by B. B stands for bulk modulus. Okay? So just substitute the value for a liquid, which is standard one. For water you assume. See what is coming. Let us do it for water. For water, B equal to 2 into 10 to the power 9 and density all of you know. So V going to be what? B by rho, that is approx this much meter per second, isn't it? Which is same as observed value. Therefore, Newton's formula is correct for Newton's formula is correct for liquids also. For gases, what to do? What can I replace for E? E can be replaced by pressure. Let us check. For gases, Newton make one assumption. Newton assumed that we are doing it in terms of sound. Sound is a longitudinal wave. We are checking formula correct or wrong for longitudinal form or longitudinal waves. Newton assumed that propagation of sound in a medium, preferably air here, maybe any gas, propagation of sound in a medium is an isothermal process. Great scientist, why did they assume? Isothermal process is a fast process or slow process? See, you are studying physics, but you are not in physics. You are just doing it for marks. It's a slow process. Any slow process can be termed as isothermal. Any fast process, adiabatic. So Newton assumed that it is an isothermal process. Heat produced or generated during compression will be, isothermal means T constant, no? Heat generated during compression will be transmitted through the surrounding and heat absorbed during rarefaction will be compensated by the surrounding. As a result, what? As a result, T remains the same, isn't it? Temperature remains the same. Because otherwise compression, temperature increase, heat will be evolved. But Newton said that heat evolved will move to the surrounding. And heat absorbed during rarefaction will be compensated by the surrounding. As a result, T remains the same. No need to ask. As a result, T equal to a constant. Now, we assume that air is ideal gas. PV equal to a constant. Therefore, PdV, VdP equal to 0. This is what? Tell, this part is what? dP by dV by V? Change in pressure or change in bulk modulus. So B equal to P. Okay? Therefore, Newton's formula now will be what? V equal to under root P by rho. Let us check. We prefer to check in air. Because some information known already. For air, standard atmospheric pressure we take 1.01 Newton per meter square, and rho is something like kg per meter cube. Okay? So it's okay. Therefore, V equal to that divided by isn't it? Just check the values here. Coming approximately 280 meter per second. But most of you remember the result. This is not velocity of sound in air. 332 or 340. But actual velocity of sound in air is approximately 332 meter per second. Isn't it? So this is almost 16, 16% less than the actual value. So this implies the theoretical value is almost 20%. Exact percentage I can't find now, just mentally I tell. Okay? 20% less than the observed value. In case of air, in case of gas also this will happen. Why? So, very interesting. Therefore, Newton's formula was needed to be modified. But no scientist, 200 years, were able to solve the puzzle. Newton gave the formula for more than 400 years back. 200 years, people had no solution. Then came Laplace, great mathematician, then physicist. Okay? So I am going to discuss Laplace's correction. Laplace argued that all this you will write if you are going for school exam. No, teacher will be very happy. Physics has some language. It is not mathematics, no? So that language you need to mention. Laplace argued that Newton was wrong in assuming the process of propagation of sound in air is an isothermal process. But then you have to give the logic why Newton was wrong. Greatest scientist so far, remembering the name of Einstein also. Why Newton was wrong? Because of Newton's versatility. Because he used to do research work in mathematics, research work in physics, all the branches. Einstein also great, no doubt. But more than 400 years back, he started everything, this man, Newton. So why he can be wrong? What is Laplace's argument? Heat evolved during compression or heat absorbed during rarefaction hardly finds any time to transmit or what exact language I told? transmit or that compensated. Compensated to the surrounding or by the surrounding, isn't it? Hardly find any time to transmit to the surrounding or compensated by the surrounding. Therefore, why this is true? Because the process is very fast. That is adiabatic process. Okay? Process is adiabatic. Equation for adiabatic process is what? PV to the power gamma equal to a constant. Equal to 0. Okay? So this implies therefore gamma p, so v equal to gamma p. So velocity now will be what? Root gamma p by rho. Alright? It is root gamma p by rho. Now gamma is what? Cp and Cv. Now gamma is Cp by Cv. This is 1.4 for air. Why? Because air is mostly diatomic. So V equal to what? 1.4 P. Rho. This will be approximately 332 meter per second. So this formula is correct. So Laplace's formula is root gamma p by rho. This is correct for gases only. Okay. Effect of pressure, temperature, and humidity on the speed of sound in air. Number one for pressure. Pressure has no effect on the speed of sound if T equal to a constant. Can you prove this? How to prove this? PV equal to nRT for 1 mole or PV equal to RT for 1 mole. For N mole that, N mole will not take. So V equal to what? Gamma M stands for what? This is a new formula, so remember, very important. M is the molecular weight. So V is root gamma RT by M. So what will be your conclusion? If T is constant, M constant, R constant, gamma is a constant, then V will remain the same. What I have written? If T is a constant. As T is constant, therefore hence pressure has no effect. On V. You can derive other manner also. You show me next class if you have another way of thinking. What is the effect of temperature? Just proved. Just seen. V equal to what? So V is proportional to root T. Therefore, velocity of sound increases with temperature. So now, during winter, you can hear velocity with larger speed or during summer. Obviously summer, because T is more, velocity will be more over there. And third one, velocity of sound will be more in humid air. And density of humid air is less than that of dry air. Okay? Clear? Understood? So for this topic, this much was required. Now let us see just one problem here. Just I am writing the sum. Velocity of sound in oxygen at STP what will be velocity of sound in hydrogen at STP? Can you find? It's very easy. Both are diatomic, so gamma is the same. If you compare 1 mole, that will be true for any number of moles. So let us go for 1 mole only, this formula only. VO2 will be what? Gamma RT by MO2. VH2 will be what? Isn't it? Therefore, isn't it? What is molecular weight of hydrogen? And oxygen?
1632.
So they have asked you to find VH2. Oxygen speed they have given. So this will be understood. Next one is very good sum. Velocity of sound at this is the last sum today's session. Huh? Just do it very first. Velocity of sound at 330 meter per second. At what temperature it will be 660 meter per second. Done? Is it done? Which formula you are going to apply?
Same.
No.
Now I know.
So V1 by V2 equal to under root. These are practice sums, not difficult sums. T1 is what? 0. I put 0, then T2 is 0. Okay, done. End of this session, you have understood.